Welcome to this video on rational equation word problems part 3 of 3, with and against the current. As a reminder, here are some brief word problem strategies that we will be using when we work through these problems. Also, remember we will be using the equation d is equal to rt, which assumes a constant rate of speed or rate of travel. This is example 8 because this is the third part of a 3-part video series. It says Ben can paddle his kayak 4 miles an hour in still water. So let's highlight that. That seems important. It takes him as long to paddle 6 miles upstream as it takes him to travel 10 miles downstream. Determine the speed of the river's current. Okay, so in this problem, we're trying to find the speed of the river's current. I'm going to call that C. So as you can see, I've already highlighted the important information, and I have also organized or labeled the unknown variable. Okay, so now I have started to organize my information by providing you with this table. So notice it's distance is equal to rate times time. So I have 3 columns, one for distance, one for rate, and one for time. Then I have 3 rows. I have an upstream, downstream, and a still. So anytime I'm going upstream, it means I'm working against the current. That means the current is slowing me down. It's taking away from my natural speed. If I'm moving downstream, I'm going with the current. So the current is actually making me go faster. And if I'm in still water, that means there is no current. So the only way I'm moving is by powering myself, paddling my own kayak. Okay, so let's see if we can start filling this out. So Ben can paddle his kayak 4 miles per hour. Is 4 miles per hour the distance, the rate, or the time? If you said rate, that is correct. Miles per hour is a measure of speed or rate. Okay, notice I put it here because it says that's how fast he goes in still water. Okay, it says it takes him as long. Okay, so I'm going to assign this the variable t. We don't know how long that is. We just know that it takes him t, minutes, hours, whatever, right? It takes him t time to paddle 6 miles upstream. So we'll put 6 miles. Remember, miles is a measure of distance. Okay, it takes him the same amount of time to go 10 miles downstream. And that makes sense, right? Because if you're fighting against a current, you're not going to be able to go as far as if the current is pushing you along and helping you. Okay? So how can we write the rate for upstream? Well, his natural rate, right, without any current, is 4. So the speed of the current, is the current helping him or hurting him if he's going against it? Well, if he's going upstream against the current, then the current is taking away from his natural speed. If he's going downstream or with the current, then the current is pushing him along and it's helping him. It's adding to his speed. So this is the completed table. So now we have to pull out our equation, d is equal to rt, and we're going to write 2 equations. We have 6 is equal to the quantity 4 minus c times t, and then we have the equation 10 is equal to 4 plus c times t. Okay, so if you want, take a minute, pause this video and think about how you would proceed. Okay, so you can do anything you want. I myself personally am going to solve both equations for t. Because remember, I don't really care about t. I'm not asked to find t. I care about c. Okay, so what I did here is I divided both sides by 4 minus c. Right, I isolated that variable. I'm going to do the same thing with this equation right here. I have 10 divided by 4 plus c is equal to t. Now what I can do is, since both of them are equal to t, right, I can set them equal to each other. I can use the transitive property or the substitution property of equality. Okay, another way to think about it is just simply to say if 10 over 4 plus c is equal to t, right, then I can put that in place of t in that equation. Okay, so that's super helpful, right? Because now what do I have? I have this beautiful proportion. I have a over b equals c over d. So I can quite simply cross multiply. It's going to give me a linear equation to solve, which is pretty straightforward. So I can just do that and then I can solve it. So it's really, this one's not that bad. Okay, so 10 times 4 minus c, 40 minus 10c equals 24 plus 6c. Okay, I'm going to add 10c to both sides. I try to move my variable terms around so that the coefficients remain positive to reduce the probability of human error. That's just my preference. Okay, subtract 24, subtract 24. Okay, so what do we get? We get 16 is equal to 16c. That's interesting. Okay, so if we have 16 equals 16c, well, we just divide both sides by 16. Okay, so c is equal to 1. Well, 1 what? Well, remember, if we look here, right, our units are miles per hour. So that's reasonable, right? It's reasonable to think that the speed of the water is only 1 mile an hour. Okay, and so if he's going upstream, right, his effective speed is 4 minus 1 or 3 miles an hour, right? And if he's going downstream, then his effective speed is 5 miles an hour. Okay, and if you wanted to, you could go back and figure out the time, right? If his speed is 3 miles an hour and he went 6 miles, he probably traveled 2 hours, right? If his speed is 5 miles an hour and he went 10 miles, well, again, it's 2 hours, right? So you could do that. Again, they don't ask you to find t, so you don't have to do that. All right, let's look at this next example. It says a boat's crew rowed 40 kilometers downstream with the current in 5 hours. The return trip upstream against the current covered the same distance, and it took 10 hours. Find the crew's rowing rate in still water. So again, I've organized my information already in a table, right? I have D, R, T. We have upstream, downstream, and still water. So let's start filling out some information. It says a boat's crew rowed 40 kilometers. Is 40 kilometers a rate, a distance, or a time? Well, this is a distance, right? 40 kilometers is distance. So distance downstream is 40 kilometers, okay, with the current in 5 hours. So we'll put 5 hours right here, okay. The return trip upstream against the current covered the same distance, and it took 10 hours. Okay, same distance, that means 40 kilometers. Okay, then it says find the crew's rowing rate in still water. Okay, so the crew's rowing rate in still water is going to be R. Okay, so we don't know what it is, we'll just call it R. Okay, so when they're going against the current, remember that means the current is hurting them, it's slowing them down, it's working against them because it's going in the opposite direction. So their effective speed upstream is whatever their rowing speed is minus the current. When they're going downstream, the current is pushing them along. Even if they stopped rowing, they'd still be moving in that direction because of the current. So it's R plus C. All right, so again, we pull out our D is equal to RT formula. So our first equation is 40 is equal to the quantity R minus C times 10. Okay, our second equation is 40 equals R plus C quantity times 5. Okay, so if you want, you can pause this video, think about how you would proceed to solve this. I myself personally am going to do exactly what we did last time, and I'm going to write it as 40 over 10 is equal to R minus C. Okay, and then I'm going to write it as 40 over 5 is equal to R plus C. Okay, so what I can do, right, makes it a lot easier to solve. Okay, so we have 4 is equal to R minus C, and then we have 8 is equal to R plus C. So instead of substitution, which we've used before, what we can do is you can use addition or elimination. If I add these two together, I get 4 plus 8 is 12. I get 1R plus 1R is equal to 2R. Okay, and then negative C plus C, of course, is 0. So then all I have to do is divide by 2, and I find that the speed of my boat, the crew, they row at 6 something. Well, what are the units? Well, it says kilometers, right? So it's going to be 6 kilometers per hour. Okay, and that's your final answer.